everyone, in continuation with our previous lecture, in this lecture we will discuss different methods to determine particle size and particle size distribution. In the previous lecture, we already studied what is the particle size, what is the shape factor, what is the polydisperse in nature, what is the monodisperse in nature, what are the equivalent diameters. So, that was the introductory part. Now, we are moving ahead towards the fundamental properties of the powder. As you know, and as all of you have studied in the physics, there is two types of properties of anything, that is one is the derived property and second one is the fundamental property. Fundamental property, for example, if I am saying that is the mass, volume, mass of the powder is the volume of the powder is the fundamental property. What it means, so the density of the powder, the density is equal to mass upon volume. So, density is derived from the mass and volume, that is why it is known as the derived property. So, here we have to study both type of properties of powder, derived properties as well as the fundamental property. So, in a fundamental property you have to study two properties and next we will study the rest of the property in it's our derived property. So, first fundamental property is the particle size and second fundamental property we will study the powder particle surface area. So, for the determination of a powder particle size along with powder particle size distribution, and what is the difference between particle size and particle size distribution, we have already discussed in our previous lecture. So, for the determination of a powder particle size there is two methods. One is the number distribution method and second one is the weight distribution method. नंबर डिस्ट्रीब्यूशन, जब हम पार्टिकल को एक पार्टिकल को मेज़र करते हैं जैसा हम माइक्रोस्कोपी में करते हैं, सो दैट इज़ नोन एज द नंबर डिस्ट्रीब्यूशन ऑफ पार्टिकल्स. When we just weigh all the particles by putting them in weighing balance, so that is known as the weight distribution. जैसे कि अगर हमने पार्टिकल को वे किया, जैसे ओके इट्स 1 ग्राम पाउडर और 2 ग्राम पाउडर और फिर हमने उसके एनालिसिस किया ऑन द बेसिस ऑफ वेट ऑफ द पार्टिकल, सो उसे हम बोलेंगे वेट डिस्ट्रीब्यूशन. यही हमने क्या किया, 1 ग्राम या 2 ग्राम नहीं वे किया, हमने क्या देखा जस्ट ओके 100 पार्टिकल्स, 200 पार्टिकल्स, 300 पार्टिकल्स. अब हम इन 100 पार्टिकल्स की स्टडी करें आइदर इन द फॉर्म ऑफ सरफेस एरिया और डायमीटर व्हाटएवर. सो दिस इज नोन एज द नंबर एनालिसिस एंड दिस इज द वेट एनालिसिस. सो पार्टिकल साइज डिटर्मिनेशन के भी दो मैथड है, तो नंबर डिस्ट्रीब्यूशन मैथड एंड सेकेंड वन इज द वेट डिस्ट्रीब्यूशन मैथड. So, weight distribution method का one way to analyze the particle by the weight distribution method is the sieving method, and sieving method is also known as the separation method. Now, what is the sieving method? How will you distinguish the powder particles on the basis of the sieves? So, sieving and in a separation method, sieving may be performed by a machine for a fixed time or until powder passes through the sieve at a constant low rate. Approximately particle size range which will be determined by this sieving method is 5 micrometer to 3 millimeter. This is a particle size range. If you suppose that the particle size range lies in between these 5 micrometer to 3 millimeter, then we have to go for the separation method for the particle size analysis. See, this is the separation method. This is a pictorial representation for this separation method. As you see in the picture, these are 4 mesh. First, second, third and fourth. When you pour or when you insert the powder or a mixture of feed, that means here it is in mixture feed that means polydisperse. अदरवाइज ऑल आर द मोनोडिस्पर्स. अगर सारे मोनोडिस्पर्स होते तो इसे सीव से एनालाइज करने की जरूरत ही क्या थी, सारे के सारे किसी एक ही सीव पे रिटेन होते. क्यों? क्योंकि सारे के सारे मोनोडिस्पर्स है. मोनोडिस्पर्स सारे के सारे या तो 1 माइक्रोमीटर के हैं या 2 माइक्रोमीटर के हैं, 3 माइक्रोमीटर के हैं, 4 माइक्रोमीटर है, तो उनके लिए सेपरेशन की ज़रूरत ही क्या है. दिस ऑल सेपरेशन, ऑल इक्विवेलेंट डायमीटर, एवरेज डायमीटर, जस्ट बिकॉज ऑफ द asymmetry in the particles. That's why, and the particles are polydispersed in nature. That's why we are studying all these methods. So, Here are 4 meshes, first, second, third and fourth. There is a mixture feed, that means the polydispersed powder particles. So, as when you vibrate this machine or this shaker, when we vibrate the motor, the particle will retain their mesh, either they retain on this mesh or this mesh or this mesh or this mesh, or whatever the particle will retain in each and every mesh. There will this is a drain point, from here they will drain, from here they will drain, from here and from there. So, in a mixture feed or in the polydispersed group of a particle, the particles who have a largest particle size will retain on the topmost sieve, and the powder particle will have a smallest particle size, they will cross this second layer, then third layer, then reaches to the bottom layer. So, in this way we can separate out the particles just by using the sieve or a mesh size. So, this is known as the basic concept or principle for the separation of a powder particle or sizing analysis with the help of the sieve shaker or a mechanical sieve shaker. So, sieve analysis is used to obtain the particle size and particle distribution of a solid material by determining the amount of powder retained on a series of sieve with a different sized aperture. Different size aperture, that means जो sieve की mesh लगी, they all have a different size apertures. Apertures, that means the opening in the sieve. So, how will you determine the powder particle size? By sieving method. Just you have a mechanical sieve shaker. In a mechanical sieve shaker, you have to set the sieves, and the most important in this case of this sieving method, the most important parameter or most important criteria is that how you have to arrange the sieves. Which sieve you have to arrange in the topmost condition and which sieve you have to arrange in the bottom line in the mechanical sieve shaker. The first point for to determine the particle size by sieving method is powder is loaded in the topmost or a coarest sieve of the assembled stack and subjected for a mechanical vibration in a sieve shaker. The particles are considered to be retained on a sieve mesh corresponding to its size. Remove sieve assembly from a sieve shaker. Weigh the powder retained on each sieve and tabulation of data and particle size as well as particle size distribution estimation. So, this is mechanical sieve shaker. Mechanical sieve shaker, here there is a number, how many sieves are arranged in this mechanical sieve shaker? 1, 2, 3, 4, 5, 6, 7, 8. These 8 sieves are arranged in this mechanical sieve shaker. That means, when you open this sieve, mechanical sieve shaker, you will find this 3, 6, 7 sieves within this mechanical sieve shaker, and these sieves are all of different number. ऐसा नहीं है कि सारी sieves same number की हैं. These sieves are of different number, and you have to arrange all these sieves within this mechanical sieve shaker. And in the topmost sieve, in this sieve we have to pour the powder particle, then rotate this sieve shaker, mechanical sieve shaker, for the 2 to 5 minutes. After operating it for 2 to 5 minutes, just switch off this and then remove out this assembly. After removing out this assembly, that means the assembly of sieve, what you have to do in the next step, you just remove now each and individual sieve, and you have to weigh the powder retained on each sieve, and whatever the powder is retained on each sieve, we have to tabulate that data in a particle size determination table. Here, this is a sieve number 4, this is a sieve number 6, this is a sieve number 8. sieve में क्या होता है? mesh aperture size, और mesh aperture size के basis पर हम sieve number देते हैं. At least sieve number दिया है तो it will represent something. Here the sieve number is 4. What is the mesh aperture size? Here the sieve number 6, mesh aperture size. Here the sieve number 8, mesh aperture size. Mesh aperture size, that means the net, that net opening. If this is like this, so this is known as the mesh aperture size. If the sieve number is 4, mesh aperture is 4760. If the sieve number is 6, mesh aperture is 3360. If the sieve number is 8, then mesh aperture size is 2380. What do you see the relationship between the sieve number and mesh aperture size? Sieve number and mesh aperture size have a inverse relation. See, here the sieve number is the smallest sieve number is 4, but the smallest sieve number has the largest mass aperture size. Here the sieve number is 8, largest sieve number, but here the mass aperture size or mass size is 2380. That means mass aperture size and sieve number have an inverse relation. If the sieve number is 18, then they have the more bigger aperture size as compared to sieve number 40. See, for example, this will be sieve number 18 and this will be sieve number 36. See, sieve number 18 and sieve number 36. If you see the sieve number 18, the mass aperture size will be bigger size here, and here the mass aperture size is this. So, when we compare the if you compare the mass aperture size and mass sieve number this sieve number is 36, mass aperture size is small. Here the sieve number is 8, but the mass aperture size is bigger. So, when you are going to arrange the sieve in mechanical sieve shaker, how will you arrange? Suppose that we have a 18 number sieve. You have a 18 number sieve, 36 number sieve, 40 number sieve, 120 number sieve and 240 number sieve. How will you arrange these sieve in a mechanical sieve shaker for the particle size analysis by the separation or sieving method? There is two ways, 1, 2, 3, 4, 5. There is a 5 sieves. So, either you will arrange like this 18, 36, 40, 120, 200. Or 200, 120, 40, 36 and 18. One way is this, you will arrange all the seats in like this. अब आपके पास ये सारे 5 सीव्स हैं, आपको इनको एक अरेंज करके ही तो मैकेनिकल सीव शेकर में लगाना है। फिर जो भी सीव को आप टॉप मोस्ट कंडीशन पे रखोगे उस पर आप पाउडर डालोगे। पाउडर डालने के बाद इस मैकेनिकल सीव शेकर को 2 to 5 मिनट्स तक चलाओगे। 2 to 5 मिनट्स तक चलाने के बाद यू हैव टू स्विच ऑफ करने के बाद हर सीव को बाहर निकालोगे और देखोगे कि 18 नंबर सीव पे कितना पाउडर पार्टिकल रिटेन हुआ, 36 पे कितना हुआ, 40 पे कितना हुआ, 120 पे कितना हुआ और 200 पे कितना हुआ। जो भी पार्टिकल रिटेन हुआ होगा यानी पार्टिकल वेट रिटेन हुआ होगा उसको हम डेटा को टैबुलेट करते हैं। फिर सिग्मा एन का फॉर्मूला लगाएंगे, देन यू विल गेट द एवरेज पार्टिकल साइज। बट बिफोर going to just analyze the weight retained on each sieve, first thing, how will you arrange these sieve in a mechanical shaker, by this method or by this method? As you see, the sieve size and sieve number and sieve mass aperture size are inverse relationship. So, 18 number, this is the right way to arrange the sieve in a mechanical sieve shaker. How? Why? बिकॉज द 18 नंबर क्या है, सबसे इन सब में सबसे कम नंबर है, सबसे छोटा नंबर 18 नंबर है, तो उसका जो मैस अपर्चर साइज होगा वो बहुत बड़ा होगा। दिस विल बी लाइक दिस। ओके, नेक्स्ट वन इज द 36, उससे भी छोटा मैस अपर्चर साइज, फिर 40 और छोटा, फिर 120 और छोटा, फिर 200 और भी छोटा। So, we have to arrange the sieve in this way. Coarest sieve should be on topmost condition and the finest sieve should be in a bottom line. अगर आप इसे इस तरह से अरेंज कर दोगे तो इसमें सीविंग ही नहीं होगी। You can't separate the powder, क्योंकि सारे का सारा पार्टिकल अगर ये बहुत छोटा स्मॉल साइज का ऊपर ही लगा दिया तो सारा पार्टिकल तो यही रिटेन हो जाएगा। How will it pass on to the lower sieve? So, we have to arrange the sieve in this way in the mechanical sieve shaker. And after operating this mechanical sieve shaker for 2 to 5 minutes, you will get the how much weight retained on each and every sieve, and then you have to tabulate the data. See, Sieving method is also known as the weight distribution. See here next we will study the microscopic method, so that will known as the number distribution. क्योंकि माइक्रोस्कोपी में हम क्या करते हैं, एक पार्टिकल को काउंट करते हैं. वेट डिस्ट्रीब्यूशन में हम एक पार्टिकल को नहीं देख रहे हैं, हम तो पूरा का पूरा पार्टिकल वे किया और उसे सीव से पास कर दिया. सो दिस इज नोन एज द वेट डिस्ट्रीब्यूशन. और जब हम माइक्रोस्कोपी से करते हैं तो उसे बोलते हैं नंबर डिस्ट्रीब्यूशन. दिस इज द टेबुलेशन ऑफ डेटा इन अ sieving method or a weight distribution. The formula for determine, see here the D sieve, D means diameter, sieve means sieve diameter, because it is the equivalent diameter. The particle are asymmetric in nature, that's why it's not an exact diameter, it's the equivalent diameter. कौन सा equivalent diameter? Sieve diameter. So D sieve, sieve diameter निकालने का जो formula है, that is the sigma ND upon sigma n. And how will you determine the sigma ND and sigma n? N is known as the frequency. Suppose that you have a 50 particles, and in among these 50 particles 40 particles of 2 micrometer. So 2 micrometer particles की frequency क्या हुई? 40. So we have to tabulate the data in this way. First one is the sieve number. You have selected 5 sieves, 18, 30, 100, 200 and 240. Now aperture size, from this 18 number sieve aperture size is 850. This is a fixed value. We will get the values from that pharmacopoeias also. 18 number sieve have a 850 mass aperture, 30 number sieve aperture size, 100 number sieve aperture size. This means these data is fixed data. Whatever sieve you have select, just according to that sieve number, whatever the data or the mass aperture size given for that sieve, you have to place the data here. Now the calculation start from here. Mean aperture size, that is known as the D. How will you determine the mean aperture size here? 850 plus 425 divided by 2 equal to 625. How will you get 635.5 here? 850 plus 425 divided by 2 equal to 637.5. In the next step, mass aperture size 425 plus 150 divided by 2, this 287.5 and so on. Here weight retained on AC, ये weight retained कहाँ से मिला आपको? This weight retained you have obtained from this here mechanical sieve सेकर में जो भी आपने sieve use की थी उन sieve को remove किया और हर sieve पे जो weight retain हुआ है that is the weight retained sieve. That is the weight retained on each sieve. Here you have selected the 5 sieves, 85 sieves, 18, 30, 100, 200 and 240. So whatever the amount of powder is retained on 18 number sieve, this is this, 30 this, 100 this, 200 this and 240 this. Total powder 19.78 है. Weight distribution है, that means हमने 20 gram powder, it may be spillage of rest of the particles. So 19.7, that means lump sum you have taken the 20 gram of powder. आपने 20 gram powder लिया था और जो top most core sieve थी उसमें डाला था, 2 to 5 minute rotate किया था. इसके बाद हर sieve पे जितना powder retain हुआ था उसे weigh करके यहाँ पे लिखा, that is the data. Now next one is the n into d. How we calculate n into d? This is the n, this is the d. 637.5 multiplied by 0.03, then you will get the 19.125 and so on. You have to complete this table. Percentage weight retain on a sieve. How will you determine the percentage weight retain? This is a percentage weight retain. What is the n? 0.03 divided by 19.78 multiplied by 100, then you will get this value and so on. You have to calculate it. Percentage cumulative weight retain. For the calculation of the percentage cumulative weight retain, in the first table you have to put the same data, 0.16 equal, here we 0.16. In the next, this is a diagonal addition, 0.16 plus 28.21 equal to 28.37. Now 28.37 plus 58.84 is 87.21. 87.21 plus 7.59 equal to this, and this plus this equal to this. So cumulative weight retain निकालने के लिए we have to diagonally add up the data. In this way you just complete this table. From this table you can calculate, this is sigma n, this is sigma nd, and how will you determine the D sieve? Sigma nd upon sigma n, 3100.76 divided by 19.79 equal to 156.76 micrometer. So this is the average particle size, or D sieve of given powder was found to be 156.76 micrometer. So, this is the particle size, and how will you determine the particle size distribution? Particle size distribution you will determine by the frequency distribution curve, and as we studied in the last lecture, for the frequency distribution curve, on x axis we have to always place the particle size and y axis in frequency. So, how will you plot the frequency distribution curve? X axis, this is the mean aperture size. In a y axis there will be three graphs you can obtain by the in a sieve analysis for the determination of particle size distribution. One graph in all these three graphs, in x axis is will be mean aperture size, in one graph y axis weight retained, percentage weight retained and percentage cumulative weight retained. You will get the three frequency distribution curve. तीनों ही कर्व में x एक्सिस में तीनों में क्या होगा, मीन अपर्चर साइज, एक ग्राफ में y एक्सिस में वेट रिटेन, एक ग्राफ में परसेंटेज वेट रिटेन और एक ग्राफ में cumulative percentage weight retain. In this way you will get the three frequency distribution curve. This weight retain is equivalent to frequency in term of the number distribution. इसी को ही हम number distribution में जिसे हम frequency कहते हैं, that is the weight retain in the case of the separation method or a weight distribution method. So, in this way you will get the average particle size as well as the particle size distribution. So, these are the advantages and disadvantages of this methods of this separation method for the determination of the particle size and particle size distribution. So, next method for the particle size determination is the microscopy method. As the name says, this method belong to the number distribution method, because in microscopy we always determine the number, we always measure each and individual particle. We can't say it's a 1 gram of powder, it's a 2 gram of powder. We say in case of a microscopy, I have determined the 100 number of particles, I have measured the 20 number of particles. So, this is based on the number distribution. इसको ही हम number डिस्ट्रीब्यूशन कहते हैं. जब भी हम एक एक पार्टिकल को मेजर करते हैं, दैट इज नंबर डिस्ट्रीब्यूशन. जब हम पार्टिकल को एक एक वे ना करके इकट्ठा एक एक पार्टिकल को मेजर ना करके इकट्ठा पाउडर को वे कर लेते हैं, दैट इज नोन एज द वेट डिस्ट्रीब्यूशन. सो माइक्रोस्कोपी मेथड इज साइज रेंज, जैसे कि हमने sieving method में पढ़ा था या separation method में पढ़ा था, that was the size range of the particle which can be best analyzed by that method was the 3 micrometer to 5 mm. Similarly, the size range is for the one thing in a microscopy there are two microscopic so one is the optical microscopy, second one is the electron microscopy. The ordinary microscope which we are using in the laboratory, where the light source of light is UV rays or a tube light, so that is known as the optical microscopy. When the beam of electron is behave as or used as a source of light, that is known as the electron microscopy, and electron microscopy is a more precise and finer as compared to the optical microscopy. So, this is the particle size range which we can easily determine with the help of the optical microscopy and electron microscopy. And how will you determine the particle size in a optical microscopy method? In optical microscopy method, this is not belong to electron microscopy. In case of optical microscope वही microscope है ordinary microscope जो आपने laboratory में use करते हो, जिसको आप focus adjust करते हो with the help by using a light source of tube light, और आप जहाँ पर window के पास light आ रही थी वहाँ जाके adjust करते हो, जो वो microscope होता है, that microscope is known as the ordinary microscope, where you are the source of light is a tube light or a artificial light or a UV rays. So, in a case of a optical microscope, how will you proceed? First, you have to calibrate the eyepiece or ocular with a stage micrometer. Stage micrometer वो micrometer होता है जो हम stage में लगाते हैं, और eyepiece या ocular वो होता है जिसके थ्रू आप उसके measure करते हो. तो we have to coincide the lines of units of the eyepiece to the stage micrometer, and by coinciding this eyepiece with the ocular eyepiece with the stage micrometer, we can calculate the calibration factor, or we can calibrate this optical microscope method. So, first step is the calibration of the optical microscope. And how will you calibrate the optical microscope? By knowing this coinciding line of this ocular as well as the stage micrometer. How many divisions of the stage micrometer or how many divisions of the optical will coincide with the this stage micrometer? After this, what we have to do, we just sprinkle the particle in the glass slide and then put that glass slide, but after that you have to just remove of the stage micrometer from the optical microscope after doing the calibration. Just instead of a stage micrometer, we have to put our slide, slide that is a prepared slide of the particle. Suppose that I am going to determine the average particle size of this calcium carbonate particles. So, what we have to do, we just sprinkle the calcium carbonate powder particles in the glass slide and put this, remove the stage micrometer after the calibration and put this calcium carbonate slide instead of a stage micrometer. And by moving this stage micrometer and observing with a ocular or eyepiece, we have to determine the powder particles, particle size of the at least minimum 500 particles we have to determine in case of this optical microscopy method. How will you determine? Just you just move that slide and then measure how many, 1, 2, 3, 4 division. 4 division if it's, this is the particle. Suppose that this is the particle and you have a, this is the particle. We can't make such type of a particle because this is spherical and all the particles are asymmetric in shape. So, if this like this, 1, 2, 3, 4. So, diameter of the particle is 4 micrometer, 1, 2, 3 micrometer, 6 micrometer. In this way, we have to determine at least 500 particles, and all the data you will obtain from these 500 particles, you have to tabulate the data in this table. This table is similar as per the size separation or sieving method. Same formula is also used here. Only the difference here, the particle size range instead of the mean aperture size, and there is the frequency instead of the percentage weight retained. In this way, you have to determine the same n into d, percentage frequency, percentage cumulative frequency, and you have to determine the average particle size by optical microscopy. But if you compare that sieving method with optical microscopy, optical microscopy is a more precise and more accurate method as compared to the sieving. Sieving is just sizing, just separation of the particles, but this method is much more tedious, and to remove of this disadvantage, we have to go for the electron microscopy. Here we can also draw the particle size distribution curve. In a particle size distribution curve, as I already told you, in x axis is always particle size and in y axis is always a frequency. Always particle size, that means this will be in your x axis and in y axis one graph, second graph, third graph. So, these three will be your frequency distribution graph, and this will be average particle size by optical microscopy method. And in optical microscopy method, we determine the projected diameter, that is why it is dP. So, now this is the advantages and disadvantages of the manual or optical microscopic method. Now next one is the electron microscope. So इन चीज़ों को remove out करने के लिए, इन चीज़ों को minimize करने के लिए, to prevent this disadvantages of this optical microscope, we can switch to the electron microscopy method. Here you can easily determine the particle, and this method is not as much as tedious as the optical microscope, where you have to remove, we have to just move up the stage throughout the experiment to determine at least the 500 particles. So for that you have to go for the electron microscopy. In the same way, electron microscopy will also give you the number distribution. One of the major disadvantages of this method is you can't, it will give the two-dimensional information of the particle. That means with the help of this optical microscopy or electron microscopy method, you can't determine the depth of the particles. So this these are the advantages and disadvantages of the electron microscopy also. Thank you. So in today's lecture, what we have studied, just we can summarize all the things. We studied what is the how will you determine the particle size. There are two methods for determination of particle size, number distribution and one weight distribution. So one method we have studied from the number distribution, that is the electron microscopy, and one method from the weight distribution, that is the sieving method. So for the determination of a particle size, we have to study four methods. in which two methods, that is a sieving and a microscopy, we have already studied. In the next lecture we will study again the next two method, that is the sedimentation method and Coulter counter method. So, for the determination of powder particle size there are 4 methods: sieving, optical microscopy, Coulter counter and sedimentation method. Thank you.